Good morning. We are continuing the lesson Biomechanics and Sports, and the topic we have discussed in previous video, that is the law of motion. In this we are discussing about the lever and its types and its application in sports. We have discussed the lever is a rigid bar, and lever helps us to do various works simply. So lever is a simple machine. Machine functions in four ways: balance multiple forces, it enhances force in an attempt to reduce total force needed to overcome a resistance. It enhances range of motion, speed of movement, so the resistance may be moved further or faster than applied force. It alters resulting directions of the applied force. In human body, there are various bones. They work as a lever. So lever rotate about an axis as a result of force, effort E, being applied to the to cause its movement against a resistance or weight. In the body, the bone represent the bar, joint are the axis, and muscles contract to apply the force. So this way this structure of bone, joint and muscle just work like a lever in our body. So resistance can vary from maximal to minimal, means maximum to minimum. Any kind of resistance may be there, means whatever the weight we are pushing, lifting, that may be differ. It may be maximum or minimum. Maybe only one bone or weight of body segment. All lever system have each of these three components in one of three possible arrangement. Means effort and resistance and the work of the lever, that we will discuss here. So lever, there are 3 points. Determine type of lever and for which kind of motion it is best suited. Axis A, fulcrum, the point of rotation. That is, the fulcrum is the point of rotation. Point F, that is the force applied, force application, usually muscle insertion, because muscle apply the force. Point R, that is the resistance application, center of gravity of the lever or location of an external resistance. So there are 3 points are there: fulcrum and force and resistance. This we have discussed. So class 1 lever, we will see here. There are 3 type of levers: type 1, type 2, type 3. So class 1 lever, first type of lever, first class lever, axis A is between force and resistance R. So that is A, it is the fulcrum. That is, the fulcrum is between the load, the force and the load and the resistance. The resistance is load and resistance and force. The force is being applied, the resistance is the weight, and fulcrum is the working, is the axis which is helping us to work easily. This is the type 1 lever. Type 2 lever, second class lever, in which the fulcrum, the resistance is between the fulcrum and force. So the resistance are between the axis A, or we can say fulcrum, and force. So one side of the bar is there is fulcrum, another end of the bar there is the force, and in between there is the load or resistance. Third class lever, in which we can see then the force is in between the fulcrum and resistance, means the force between axis A and resistance R. So this three way the lever work. So again we can see here class 1, there is the fulcrum is at the middle, we can see A is written here. One side of one end of the bar there is the force, and another end is there is the resistance. Second, we can see then second class lever, that is the resistance is in between the fulcrum and force. One end of the bar there is the, we can see the fulcrum is there, another end there is the force, and between there is the resistance or weight. Third, we can see then there is the force is at the middle, and one end there is the fulcrum, and another end there is the resistance. So these are three type of the lever. The example, one more example we can see here, like efforts. Efforts mean that is the force being applied, the load is resistance, and the fulcrum is at the middle. So this way the load is, the person can lift this load easily because of this fulcrum. The effort means that is the force being applied, one end there is the load, and there between there is the fulcrum, because this is the due to the first type of lever. We can see type 1 lever, FAR, it is also known as FAR. Second type of lever we can see, then the efforts are there and the fulcrum is there at one end effort is there, and in between there is the load. The person is moving heavy weight through the in the trolley through the help of this fulcrum tire. So efforts are putting from one end. So second type of lever we have seen. Third type of lever we will see here then. In third type of lever, here we will see then the load is at the middle, efforts are there. The third type of lever we will see, there is the load is at one end and the efforts are at the middle, and the fulcrum is at the another end. So this way the work is done with the help of the lever. These type of machines, these type of levers are found in our body. Musculoskeletal system arrangement provide the three type of machines in producing movement. Lever, very common, wheel axis, wheel axles, and pulleys. These all work as a lever. Type of levers in human body. Human moves through a system of levers. Levers cannot be changed, but they can be utilized more efficiently. Lever is a rigid bar that we have told you in previous video also. A rigid bar that turn about an axis of rotation or a fulcrum. Axis point of rotation about which lever moves. Joints and bones and muscles are working as a lever in our body, and joints are working as a axis. In the human body, levers are made up of the joint, fulcrum, and the bones that connect them to the object being moved. So this is the lever and its type. Various examples I have given you, so then you can understand the lever and its type. Here are again see according to the bones and joints we can see here the lever and its types in our body. Human leverage for sport skills require several levers. Throwing a ball involves lever at shoulder, elbow, and wrist. The longer the lever, the more effective it is imparting velocity. A tennis player can hit a tennis ball harder with a straight arm, drive that drive than with a bent elbow, because the lever including the racket is longer and move at the faster speed. Another one we will discuss here next is the equilibrium. Equilibrium and its types, dynamic and static equilibrium, and center of gravity, and its application in sports we will discuss here now. First we will come to the equilibrium. Equilibrium, state of zero acceleration where there is no change in the speed or direction of the body. We can say equilibrium the stage where we balance the body weight on both sides of our body. It is static or dynamic. Balance, ability to control equilibrium, either static or dynamic. So equilibrium is the balance ability to control our body and balancing the body weight. Static equilibrium we will see first. Body is at the rest or completely motionless. Static equilibrium, the equilibrium of the body when the body is at rest or completely motionless. That time when we are balancing the body, that is known as the equilibrium, static equilibrium. Dynamic equilibrium, all applied the inertial force acting on a moving body are in balance, resulting in movement with unchanging speed or direction. Dynamic equilibrium, to control equilibrium and achieve balance, stability needs to be maximized. So while we are our body in its motion, that time making the balance of the body and giving stability to the body, that is known as the dynamic equilibrium. The principles of the stability. Stability is the resistance to a change in the body's acceleration, disturbance of the body's equilibrium. Stability is enhanced by determining body's center of gravity and appropriately changing it. Center of gravity, what is center of gravity? That is the point at which all of body's mass and weight are equally balanced. Equilibrium is possible by finding the center of gravity. So that's why the point at which all the body's mass and weight are equally balanced or equally distributed in all directions is known as center of gravity. Balance, important in resulting and moving bodies. So center of gravity we understand. General factors applicable to enhancing equilibrium, maximizing stability, and ultimately achieving balance. A person has balance when the center of gravity falls within the base of support. A person has balance in the direct proportion to the size of the base. The larger the base of support, the more balance will be there. That is very basic that we know. Then the larger base gives us good support, and a smaller base there is difficulty of finding the center of gravity. A person has balance depending on the weight, the mass of the body. The greater the weight and more balance. A person has balance depending on the height of the center of gravity the lower the center of gravity, the more balance. So height, we have to find the center of gravity for balance. A person has balance depending on where the center of gravity is in relation to the base of support. Balance is less if the center of gravity is near the edge of the base. These are the principles of the balancing. Center of gravity can be defined as the single point at which all parts of an object are equally balanced. A person's center of gravity can change depending on their body position, as the center of gravity is the exact point where all parts of an object are equally balanced. So, this we understood that the equilibrium and center of gravity. In this picture we can see here that the center of gravity of the person's body, the point we can see where the center of gravity is there for making the balance. So all the equilibrium and center of gravity, these are making the person balanced and stable. For a normal human being standing upright, their center of gravity lies around the area of their navel. That we can see white point is the center of gravity and standing position normally. So this is very important to find out the center of gravity while we are making balance. In case of sports, it is highly required. We can see various pictures I am showing you where center of gravity we have find. The center of gravity can also lie outside of an object, especially if the object is bent over a leaning in a certain direction. Like here we can see the center of gravity is outside of the body. In case of the chakrasana the person is doing, the center of gravity lying sometimes lies outside of the body also. So the line of gravity is the vertical line that passes through the center of gravity to the ground. If the lines of the gravity falls within the object base of support, its contact with the ground, the object is relatively stable. If the line of gravity falls outside the object or base of support, it contact with the ground, the object is relatively unstable. So these are the facts with the center of gravity. We can see in the pictures also we have shown you. Then when the center of gravity is inside the body, when the center of gravity lies outside of the body. So stable position and unstable position. Then we have seen the base of support, BOS, is the area within the object's point of contact with the ground. The larger the area the base of support covers, the more stable an object will be. The base of support should be larger. Like in first picture we can see, then base of support, like how often person is more stable. Base of support, that is BOS. The object on the left is more stable because of its relatively larger base of support. So wide base of support, one picture narrow base of support we have seen. Then we will come to the another topic, that is the force, centripetal and centrifugal force and its application in sports. Force. The forces either push or pull on an object in an attempt to effect motion or shape. Without force acting on an object, there would be no motion. Force product of mass times and acceleration. Mass, amount of matter in our body, that we know. That's why the formula of force is F equal to m into A. Momentum, quantity of motion, equal to mass and time velocity. The greater the momentum, the greater the resistance to change in the inertia or state of motion. The production of force, the application of force, the factors, these factors related to the movement activities, the production of force, how much force we are producing, the application of force, how we are applying the force, and the absorption of force, how much force is being absorbed by the object. The production of force we will see here. The production of force, external forces are produced from outside the body and originate from the gravity, inertia, or direct contact. Only muscles can actively generate internal force. But tension in tendon, connective tissues, ligament, and joint capsules may generate passive internal force. So directly the muscles are producing, and rest of the supportive structure is producing the passive force, that is the production of the force. The production of force, the appropriate sequence to get maximum force is necessary. Next is the application of force, we will see here. A force of an object must be applied in the direction in which it has to travel. All activities require the summation of the forces from the beginning of the movement in the lower segment of the body to the twisting of the trunk and movement at shoulder, elbow, and wrist joint. So, force should be applied in the direction where we have to move the object. The absorption of force we will see here. Significant mechanical loads are generated and absorbed by the tissues of the body. Tension in tendons, connective tissues, ligaments, and joint capsules may generate passive internal force, that we know. So, mechanical loads are generated and absorbed by the tissues of the body. So, the body and object sometimes absorb the force. The absorption of force, see here, internal force can be absorbed. Fracture the bone, when the force is being absorbed by the bone, that will be fractured or dislocated the joint. It disturbs the muscles or connective tissues, they may be teared when the body is absorbing the force. To prevent injury and damage from tissue deformation, the body must be used to absorb energy from both internal and external forces. Because absorption of force and we are not absorbing the energy, so then that can cause damage. Centripetal and centrifugal force we will discuss now. Two type of forces, centripetal and centrifugal force. When an object is rotating around the field, around the fixed axis in a circular path, two opposing forces act on the object, centripetal force and centrifugal force. So, around the axis on a circular path, the forces are two type of forces, centripetal and centrifugal force. So, we must remember, when the object is moving on a fixed axis in a circular path, two opposing forces act on the object. First we will discuss the centripetal force. The force which keeps the body moving with a uniform speed along a circular path, and it's directed along the radius towards the center. Clear? Centripetal force means while the object is moving in a circular path and it is controlled or directed by the center or the radius towards by the radius of the circle. In case then the control or the direction is missing, so it will cause the object to move towards the centers. The object will fall into the center. While centrifugal force, we will see when centrifugal force we will see here, when centripetal force act upon a body, another force equal to the centripetal force but opposite to the direction also act upon it. This force is called centrifugal force, because speed of the object when it is moving fast, so then the opposing force that works while the centripetal force is acting on it, that is known as the centrifugal force. And in this case, when the control from the center is missing on an object, the object will move, it will cause the object to move away from the center. Like when you are holding any object by tying a thread on it and moving in a circular path by your hand, means that it is controlled by the thread, but while the thread is teared, so that object will move out from the circle, it will move away from the center. So there are two type of these forces are there. Application of these forces in sports, then in the performance of various sports skills such as throwing, many applications of the law of leverage, motion and balance may be found. In throwing, the angular motion of the levers, especially bones of the body, trunk, shoulder, elbow and wrist, is used to give linear motion to the ball when it is released. We can see here then the force and its application. Application of centripetal and centrifugal force while the person is doing skating. Various another examples we will see here. Application of centripetal and centripetal force. Force is applied there. In case of playing the sports activities, various type of sports are there, we have seen. So this is all about this chapter. I will come with the new topic in the next chapter.